Hey everyone, in today's video, we're going to go over a variety of different gas laws. We're going to start off with Boyle's law, then go into Charles' law, and then finish with the ideal gas law. We're just going to go through them all step by step. So this first problem reads, a cylinder is filled with 10 liters of gas and a piston is put into it. The initial pressure of the gas is measured to be 117 kPa. The piston is now pushed down, compressing the gas, until the gas has a final volume of 720 liters. Calculate the final pressure of the gas. Round our answers to three significant figures. So the best way to tackle these problems is just to figure out what gas law we're using. So in this first one, we're using Boyle's law, and then we have to know the equation for that. And the equation for Boyle's law is just P1 V1 is equal to P2 V2. The P1 is our initial pressure, and our V1 is our initial volume, and then our P2 is our final pressure, and our V2 is our final volume. So let's go ahead and go through the problem, and we're just going to break down what each one is. So our initial pressure, it gives us right here, it's 117 kPa. And then we can just leave that in kPa, we don't have to convert that into anything. And then it gives us a cylinder is filled with 10 liters of gas. So to that 10 liters, that's our volume. And then we can just go ahead and leave that in volume. And then it says the piston is pushed down, compressing the gas, until the gas has a final volume of 720. So that's our final volume. It gives us those three units, and we are left to find x. So we don't know what P2 is, and that's what we have to calculate for. So if we go back to our initial equation, P1 V1 equals P2 V2, we can go ahead and try to theoretically manipulate the equation to where we just have P2 by itself. And the way we're going to do that is we're just going to divide V2 on both sides, and then that's going to give us over here P1 V1 over V2 is equal to our P2. So we have everything we need to solve the problem. So let's just go ahead and plug everything in. So we have 117 kPa. We don't have to include units in our equation. And then we're going to times that by our V1, which is 10 liters, and that's going to go over our V2, which is 720. And then this is equal to P2. So we can go ahead and calculate that. So 117 times 10, that's going to give us 1,170. And we still have to divide that by 720. And if you just do that really quickly, 7.2, that's going to give us a P2 that equals 162.5. And then the initial question asks us for 3 sig figs, so we can just go ahead and put 163. And that's our final P2. And that's how you do the Boyle's law problem. Okay, let's go ahead and take a look at this next problem. So it reads, an Arctic weather balloon is filled with 48.2 liters of helium gas inside of a prep shed. The temperature inside the shed is 5 degrees Celsius. The balloon is then taken outside where the temperature is negative 10 degrees Celsius. Calculate the new volume of the balloon. You may assume the pressure on the balloon stays constant at exactly 1 atmosphere, and then it's going to ask us to round our answer to 3 significant figures. So like I said, the first thing to do with these kinds of problems is just to figure out what law you're using. So in this formula, or this equation, we're going to be using Charles' law. So Charles' law is simply V1 over T1 is equal to V2 over T2. So if we break down our problem, we'll have 3 different numbers, 48.2, 5 degrees Celsius, and negative 10 degrees Celsius. So we can break it down. Our V1, which is our initial volume, is going to be 48.2 liters. And then our T1, which is our initial pressure, or initial temperature, is equal to 5 degrees Celsius. And for these equations, we can't actually use Celsius. So what we have to do is convert that to kelvins. So in order to convert that to kelvins, all we have to do is just add 273.15 to that 5 degrees Celsius. So we add 273.15. That gives us 278.15. Let me just move this over really quickly. So we have our initial temperature of 278.15 degrees, or this is in kelvins. So, and then we have our V2, which we don't actually know yet. We don't know our V2 yet, so we can just leave that as X. And then we have our T2, which is negative 10 degrees Celsius. And like I said, we can't actually use Celsius, so we'll just add the 273.15, and that'll give us 263.15. So these are all of our variables. We are solving for V2 here. So if we go back to our initial equation here, we have V1 over T1 is equal to V2 over T2. We're looking for V2. So what we can do here is we can just make V1, and we can just multiply it by T2 over T1. And so now this is our new equation, and we can use this equation. We can use this equation to solve this this problem. So we go ahead and plug everything in. We have V2 is equal to 48.2 times our T2, 263.15 over 278.15. And these are both in Kelvin, so that's fine. So if we go ahead and calculate that, this gives us, let's see here, 0.9461. And then we still have to multiply that by 48.2, 0.9461. And that gives us a V2 that's equal to 45.602. And it asks us for 3 sig figs. So our final V2 is equal to 45.6. And that's going to be in liters. And that's how you do the Charles Law equation. Alright, so we have one more question here. It reads, we have 6.10 moles of carbon monoxide gas in a container with a volume of 27.8 liters. The temperature is 66 degrees Celsius, and we have to calculate the pressure of the gas. We're going to round that to 3 sig figs as always. And like I said, the first thing to do in these problems is just to recognize the gas law at play. So this gas law is going to be it's the ideal gas law, and that equation for that is capital PV is equals to lowercase n RT, capital RT. So I'm going to explain what each letter represents. So P is going to be the pressure, and in this case, this is what we're solving for. V is going to be the volume, and then n, lowercase n, is just the number of moles of the gas, so it gives us the number of moles, 6.10. And then R, that's just the ideal gas constant. So I'll explain that later, but it's always going to be the same number. And then T is just the temperature. And remember, we can't use Celsius, so we're going to have to convert that to Kelvin. So let's just go ahead and rearrange this. So out of this problem, it's asking us for the pressure of the gas. So we have everything else, we just don't know the pressure. So we can go ahead and get PV equals nRT, and we can just divide each side by V, and then that's going to go ahead and give us P is equal to nRT capital over V. So that's our new equation, and I guess we can go ahead and grab all of our variables, and we can go ahead and try to solve for each one. nRT. So it gives us our N, and that's 6.10 moles. And then it also gives us our volume, which is 27.8 liters. Be sure to include the unit. And then R, this is the ideal gas constant, and this is always going to be 0.08216, and then it's going to be liters per atmosphere per mole. I don't think I have space for that, but that's what it's going to be. And then we have our T, which is 66, but remember, in order to get we have to get it to Kelvin, so we have to do 66 plus 273.15, and that new value is going to be 39.15 in kelvins, and then we don't know our pressure yet, so that's what we're solving for. So our equation then becomes P is going to be equal to, in parentheses, 6.10, that's our moles, times our ideal gas constant, which is 0.821, and then we're going to times that by 3 339.15. Let's go ahead and just move that over to give myself some more space. Okay, there we go. Oh wait, let's go ahead and just move it over a little bit, not so much. Okay, so we have that as P is going to be equal to our nRT, and then that's going to be over our volume, which is 27.8 in liters. So now we're just going to go ahead and calculate the values or our pressure. So first we're going to multiply 6.10 times 10.0821. So let's go ahead and do 6.10 times 0.0821, and that's going to give us 0.50081. So we're going to do 0.50081, and we're going to times that by our 339.15. Let's go ahead and do that really quickly. Times 339.15, and that's going to give us 169.849 divided by our B, which is 27.8 in liters. And then we can go ahead and divide that 169.849 divided by 27.8, and that's going to give us our final answer of 6.109, or if we want to get 3 sig figs, we can round up to 6.11 atmospheres. This is our pressure. So now if we want to rewrite the equation, we could, but I'm not. It's just going to be 6.11 atmospheres, and that's our final pressure. Alright, we just went through a Boyle's law, a Charles law, an ideal gas law. That's it for this video. If you found the video helpful, maybe subscribe or like, leave a hate comment, do whatever. If you have any other questions or want me to go there a different topic, just let me know in the comments below or send me an email. That's going to wrap up today's video. Thanks for watching.